What if I told you, right now, an alien traveler is passing through our solar system older than the Sun itself? MC number 1, this isn't science fiction. It's 3I Atlas, the third confirmed interstellar visitor ever seen by humankind. MC2, in July 2025, the Atlas Survey Telescope in Chile spotted something strange. A faint, fast-moving object streaking across the sky at 58 kilometers per second too fast to belong to the Sun's family. The orbit? Hyperbolic. Translation: this thing wasn't from around here. It was just passing through. Astronomers scrambled for data. They knew this cosmic stranger wouldn't linger long. Cut to time-lapse of stars streaking past. Each hour mattered, every observation window shrinking as the object slipped back into the void. Early brightness measurements stunned everyone. 3I Atlas wasn't acting like a normal comet. Even far from the Sun at distances where most comets sleep, this one was awake, glowing, venting gas, and shedding dust. That meant one thing: hypervolatiles. Substances so unstable they vaporize even in the frozen dark. MC3, these exotic materials hinted at something ancient, maybe older than our solar system itself. Scientists estimated its age between 3 and 11 billion years, meaning it could predate Earth, the Sun, and everything we know. Quote, it's a time capsule from a dead world, a message carved in ice. To put it in perspective, only 2 other interstellar visitors have ever entered our cosmic neighborhood. In 2017, Oumuamua, the cigar-shaped mystery that started all the alien probe debates. In 2019, 2I Borisov, a classic comet with an alien twist. MC4, but 3I Atlas? It's different. Faster than both. Older. More unstable. A ghost of a broken planetary system. As the data poured in, scientists realized this wasn't just a new comet. It was a window into another star system's past, material born around a long-dead sun, frozen and flung into eternity. What secrets were trapped in its icy core? What could it reveal about the chemistry of other worlds, the ones that came before ours? Comet glowing faintly in black space soon, 2 of humanity's most powerful eyes, Hubble and James Webb, would aim at this interstellar wanderer. And what they found next changed everything.
When humanity's greatest telescopes, Hubble and James Webb, turned toward 3I Atlas, what they saw defied expectations. MC number 1, this wasn't just a frozen rock from another star. It was alive with motion, light, and chemistry beyond imagination. On July 21, 2025, Hubble captured a sequence of crystal-clear images of the comet when it was still 446 million kilometers from Earth. Even at that distance, the data revealed something stunning: a delicate, teardrop-shaped coma surrounding a tiny icy heart. Cut 2. Zoom-in animation of glowing nucleus. For months, brightness readings had tricked scientists into believing 3I Atlas was massive. But Hubble's razor-sharp vision told a different story. The nucleus was much smaller than predicted, somewhere between 440 meters and 5.6 kilometers wide. Still large enough to survive the journey, but far smaller than models had suggested. That placed 3I Atlas right in the sweet spot between its predecessors: smaller than Borisov, larger than Oumuamua. MC number 2, but size wasn't the real surprise, it was behavior. Its orbit confirmed what everyone suspected: it wasn't bound by the Sun's gravity. This was a true wanderer, a fragment of another world, just passing through our system for the first and last time. Then came James Webb, armed with infrared eyes capable of seeing what no human telescope could. Using its near-spec near-infrared spectrograph, Webb's team, led by Dr. Martin Cordner, dissected the light coming from the comet's coma. MC number 3. What they found changed everything. The data showed strong signals of carbon monoxide, and carbon dioxide CO gases that vaporize at incredibly low temperatures. In contrast, water vapor was weak, almost absent. That meant 3I Atlas was already releasing gases long before sunlight could melt water ice. Quote, it's a comet powered by alien chemistry. In simple terms, this traveler wasn't made of the same stuff as our solar system's comets. It was rich in hypervolatile compounds, ices that could vaporize in the deep cold of interstellar space, hinting at its birth in a frigid alien system far beyond our sun. MC number 4, but then came the most bizarre clue, the dust pattern. Normally, a comet's tail stretches away from the sun, pushed by solar radiation. Yet in Webb's imagery, some dust seemed to move toward the sun. That shouldn't be possible, unless something inside the comet was violently reshaping the way light scattered. Scientists proposed that jets of CO gas were bursting from beneath the comet's crust, flinging fine grains in all directions. As FX's deep rumbling jet sound, together Hubble and Webb painted a portrait of an object both fragile and restless, not a dead lump of ice, but an active relic of a vanished planetary system. One that survived billions of years adrift, only to flare alive once more when it met our sun. To the astronomers, 3I Atlas was no longer just an interstellar visitor. It was a storyteller, whispering secrets of how worlds form and die across the galaxy. But just when scientists thought they finally understood it, something happened that flipped the entire narrative. The comet suddenly grew 5 times brighter than predicted. No telescope had caused it. No sunlight anomaly. It was real, a flare-up so powerful it caught the attention of NASA's test mission, and that's where the mystery deepens. What caused this surge? What buried engine could make an alien comet ignite in the dark? The answer lay hidden, not in space, but in archival data taken before the comet was even discovered. One night, 3I Atlas did something no one expected. MC number 1. It suddenly blazed 5 times brighter, lighting up the dark like a cosmic flare. This wasn't a glitch or a telescope illusion. The surge was real, and it shocked astronomers worldwide. Something inside this interstellar traveler had awakened. The story begins with a spacecraft that wasn't even built to study comets, NASA's test mission. TESS, or the Transiting Exoplanet Survey Satellite, scans the sky to find distant planets by tracking tiny dips in starlight. But along the way, it captures countless other cosmic objects, including, by sheer chance, the early traces of 3I ATLAS. MC number 2. When researchers dug into the archived test data, they found something mind-blowing. 3I ATLAS had been secretly photographed a full month before its discovery, between May 7th and June 2nd, 2025. Those forgotten images revealed the first chapter of its awakening. Astronomers Adina Feinstein, John Noonan, and Daryl Seligman analyzed the faint smudges of light and calculated that its brightness should have increased only slightly, maybe by a factor of 1.5 as it neared the sun, but instead, it quintupled. MC number 3. 5 times brighter, far too intense to be mere sunlight reflection. So, what could make an alien comet suddenly self-illuminate like a miniature star? Quote 3I. Atlas wasn't just reflecting sunlight. It was generating its own light. That could only mean one thing: violent outgassing. It was producing its own glow through an explosive release of trapped gases, like a frozen volcano erupting in slow motion. But there was another puzzle: distance. At the time, 3I Atlas was still around 6 astronomical units from the Sun, roughly near Jupiter's orbit. At that distance, water ice should remain frozen solid. And yet, it was spewing vapor and dust like a comet for closer to the Sun. MC number 4, something other than water was fueling it. The leading theory pointed to hypervolatile ices, materials like molecular hydrogen, carbon monoxide, or nitrogen. These substances can sublimate even in the deep freeze of space, releasing energy in massive bursts. It was as if the comet was waking up early, venting from within while still enveloped in interstellar cold. This revelation stunned scientists. If true, it meant 3I Atlas had likely formed in an extremely distant, frigid region of its home star system, maybe even beyond the equivalent of the Kuiper Belt, where sunlight barely reaches. MC number 5, that's where the most volatile elements hide, ancient, untouched, and ready to burst to life when stirred. These ices acted like time capsules, preserving alien chemistry from billions of years ago. When sunlight hit them, they cracked open, releasing the scent of a long-dead world. But perhaps the most exciting part came next, the test light curve. Its pattern wasn't smooth, it was chaotic, pulsing, and unpredictable, like a heartbeat with no rhythm. For the first time, scientists had recorded the emotional pulse of an interstellar comet, its brightening, fading, and roaring to life again as it crossed the cosmic void. That wild light curve hinted that the comet's surface wasn't stable at all. Maybe fracturing, venting, or reshaping as it traveled. It wasn't dying, it was transforming. Each flash, each surge of brightness was a signal, a flare from a frozen survivor telling us how alien chemistry behaves beyond our sun. MC number 6, astronomers realized that, unlike Oumuamua or Borisov, 3 Atlas was alive with volatility. A chemical engine still running after billions of years in the dark. It wasn't just another visitor. It was a teacher, revealing how worlds form, collapse, and scatter across galaxies. And just as scientists began piecing that puzzle together, the comet revealed something else. Another signal, another kind of light. A chemical whisper that would change everything we thought about interstellar origins. Just when scientists thought they had mapped every secret of 3 Atlas, it spoke again. MC number 1. This time, from the ground. And what Earth's most powerful telescope found changed everything we thought we knew about interstellar chemistry. In August 2025, astronomers turned the mighty Gemini South telescope in Chile toward the fading light of the alien comet. Using its multi-object spectrograph, they recorded new images that glowed with life, a widening coma and a faint, ghostly tail stretching across the background stars. MC number 2, but within that faint blue haze, was a chemical signature that would rewrite history. Gemini detected the unmistakable emission of cyanide gas, a clear marker that sunlight was now warm enough to sublimate ice within the comet's nucleus, freeing gases long trapped inside. That single signal proved one thing. 3 Atlas was a true comet, not a dry interstellar rock like Oumuamua. The process was simple but profound. As hydrogen cyanide HCN escaped from the ice, sunlight broke it apart into free CN molecules, and those emitted a vivid, recognizable blue glow. But as researchers compared the cyanide signal with another gas, diatomic carbon C, they noticed something strange. 3-1. Atlas was carbon chain depleted. MC. Normally, comets born near stars are rich in heavier carbon molecules like C and C, clues to complex organic chemistry. But this one, barely any. That meant one thing: its birthplace must have been freezing cold, far beyond its parent star's warmth, where heavier carbon molecules never formed or didn't survive. This isn't just an alien comet, it's chemistry from a world of eternal night. Even more astonishing, this chemical fingerprint matched only one other known interstellar comet, Borisov. Both were rich in cyanide but pouring complex carbon chains. Could that mean they came from similar star systems? MC number 4, or are we only seeing one specific kind of interstellar traveler, those that survive because they formed in the coldest, most stable regions of the galaxy? Scientists began to speculate that most interstellar comets might be carbon-poor survivors from icy outer zones, the chemical outskirts of alien solar systems. That would make 3 Atlas and Borisov siblings of a sort, travelers from similar types of worlds that froze solid before time could destroy them. Gemini's data had already rewritten textbooks, but then came a surprise from the unlikeliest source, to amateur astronomers. MC number 5, during a total lunar eclipse on September 7, 2025, skywatchers Michael Geiger and Gerald Raymond in Namibia photographed the dark red moon and noticed something peculiar: a faint emerald-green comet drifting across the background stars. It was 3 Atlas, and it was glowing green. That shouldn't have been possible. Only comets rich in diatomic carbon produce that distinct green hue, a fluorescent light at 518 nanometers caused when sunlight excites C molecules. But just weeks earlier, Gemini's readings showed that 3I Atlas was depleted in C. So, how could it glow green at all? The answer, scientists suspect, is buried beneath its surface. As the comet moved closer to the sun, sunlight may have cracked open deeper layers, exposing new volatile pockets that had never seen space before, regions rich in diatomic carbon trapped for billions of years. It's possible that the comet was breaking apart, venting gases from ancient layers untouched since its formation. Glowing emerald coma expanding outward. That sudden green flare wasn't just beautiful, it was a sign of transformation, proof that the comet was still evolving before our eyes. It came frozen from another star, and it's melting into memory before ours. Every color, every outburst, every molecule it released told a story, not of destruction, but of revelation. Even in its fading, 3I Atlas was teaching us how alien worlds live and die. But this wasn't the end. Because when scientists thought the mystery was over, a controversy ignited, one that brought Avi Loeb and the question of alien technology roaring back into the headlines. And that's where we head next, into the most heated debate of the entire 3I Atlas story. By late 2025, 3I Atlas had revealed more about itself than any interstellar visitor before it. But the story wasn't over. MC number 1, because its final act, the way it scattered light, broke the very rules of physics. The breakthrough came through a technique few outside astronomy ever hear about, polarimetry. Instead of measuring how bright something is, polarimetry studies how light twists and aligns after bouncing off dust or gas. It's like reading the fingerprints of light itself. In September 2025, astronomer Dr. Zuri Gray and her international team used telescopes across Chile, the Canary Islands, and Bulgaria to perform the first polarimetric analysis of 3I Atlas. The results: absolutely unprecedented. The comet displayed an exceptionally deep and narrow negative polarization branch, light waves polarized parallel to the scattering plane instead of perpendicular, like in every known comet. Translated simply, it was reflecting sunlight backward. No comet, asteroid, or interstellar object had ever done that. Even to Borisov, its closest cousin, behaved normally. That meant 3I Atlas wasn't just chemically alien, even its dust physics belonged to another world. It didn't just travel from another star, it carried that star's light behavior with it. The most likely explanation: its dust grains were exceptionally small, pure, and smooth, possibly coated in exotic ices or compacted in ways never seen in our solar system. Such textures could form only in ultra-cold, ancient environments, maybe even around the first generation of planetary systems in the Milky Way. That made 3I Atlas potentially the oldest physical relic humanity had ever observed up close. A cosmic fossil from the galaxy's youth. But as the scientific data poured in, another storm brewed. A familiar name reappeared. Dr. Avi Loeb, the Harvard astrophysicist known for suggesting that Oumuamua might be alien technology, released a new paper with a bold claim. What if 3I Atlas wasn't natural either? Loeb argued that early estimates of the comet's large size made its interstellar arrival statistically implausible, that such a massive object shouldn't randomly wander into our solar system. His controversial conclusion: perhaps it was artificial. The headlines exploded, social media filled with debates, and for a brief moment, the world wondered, had we just witnessed alien engineering drifting through our skies? But science moved quickly to test the claim. Peer-reviewed data from Hubble and James Webb had already revised the comet's true nucleus size down to no more than 5.6 kilometers, far smaller than Loeb's assumption. Most of its light, researchers confirmed, came not from a solid surface, but from its coma, a glowing envelope of gas and dust. The mysterious course changes Loeb cited turned out to be normal outgassing thrusts, tiny jets of CO nut. Like, share, and subscribe for more cosmic stories that remind us we're old travelers in the same galaxy.